How are you? Good, good.
Are you going to explain
Going to explain what?
the extra credit email you sent out?
I didn't even know there were other ones.
I can.
I
Yeah.
mean, do you mind? Because I read the email and it kind of makes sense, but it kind of makes
Okay.
sorry, if you don't mind.
Okay. Okay. Let's go ahead and get started back in chapter 8 today. Okay. So we'll try to get most of it finished. I did want to explain I sent out an email about extra credit. And it was just basically that's just an opportunity for you if you haven't gotten your 5 points for the first test by attending the career fair or doing something else on campus. This is just another way that you can get those 5 points. Okay. So there's the focus group, and you can also take the survey. I'd much rather you attend the focus group, but if you take the survey, that's fine too. Okay. Just send me an email saying I took the focus group survey and I can give you your 5 points, or if you attend the focus group itself, they'll have a sign-in sheet, and there's I think two this week that you can attend. Also, let me remind you, anybody interested in the financial literacy student group, we're having a meeting today at 2 o'clock. We're putting together a program for, I want to say it's Tuesday, November 15th, I think. It's going to be at 4 o'clock. It's going to be I think it's going to be in the stables. So we will have more about that in terms of what we're going to talk about. It's about an hour long. So I would encourage you also to kind of set that time aside if you can to attend that, simply because two reasons. One, it's good for you, and two, we'd like a good student turnout. So if you've got friends, you've got fraternity brothers, sorority sisters, group members, residential college people, whatever, we'd like to get as many people there as we could on the 15th. All right, now, we left off. We were talking about statistics, and I understand that is not most people's favorite thing to talk about, so we're going to try to get through this with as little pain as possible. And we talked first about, we kind of talked about measuring the risk of a single asset. And we started with standard deviation. So we went through the calculation of standard deviation. And so we went through these slides. And we kind of worked our way through this formula. And I had the standard deviation for asset A down here that I worked using the formula. And then we went through together and worked the standard deviation for asset B. And hopefully all of you sort of understand that you're going to see a question like this on the next test. Okay, I can promise you there's going to be a standard deviation question. And so if you can work that, also we took a look at, how does the standard deviation work in terms of a normal probability distribution? How can we use it? Okay, we know we can come up with a number, but what does it mean to us? So we went through and we talked about how if we have a stock, there was a 68% chance that a return would fall within a certain area and a 95% chance and a 99% chance. So hopefully the standard deviation makes a little bit of sense to you in terms of what does that number tell me and how can it help me in terms of being an investor or being maybe a manager of a corporation, or there's, again, lots of other ways that we can use it. So we stopped here. Now, we're going to talk about a second way to measure the risk of a single asset. And the second way is something called the coefficient of variation. Now, it sounds a little more impressive than standard deviation, but actually it's much easier to calculate. The only difference is, and really the only problem is, if you have the standard deviation given to you, you simply take the standard deviation for an asset divided by the expected return. Now, if you don't have the standard deviation given to you, you have to calculate that first. But it says the coefficient of variation, or the CV, is a measure of relative dispersion. Now, the standard deviation was an actual measure of dispersion. This is a relative measure. So what this means is that if we're comparing assets with different expected returns, and most investments, most assets have different expected returns, we would use the coefficient of variation, because what we're doing is we're standardizing the number that we come up with to use for comparison. So it's a measure of the relative dispersion that is useful for comparing the risk of assets with different expected returns. And the way we use this is just like with standard deviation. The higher the coefficient of variation, the higher the risk of the asset. So you will have to calculate standard deviation, and you will have to calculate the coefficient of variation. But it's really easy. The higher the coefficient of variation, the higher the risk level. Now, I'm not going to really get into the metrics behind this just a lot, okay, because that's a little bit, I think, beyond the level of this class. But this is for our two assets that we've been dealing with in the entire chapter. This is how you would calculate the coefficient of variation. So we would simply take the standard deviation for asset A, which we've calculated, divided by the expected return. So the coefficient of variation is 0.094. And for asset B, this is the standard deviation, this is the expected return, and this is the coefficient of variation. Now notice the coefficient of variation for asset B is higher than that for asset A. Unlike standard deviation, where we could simply use the plus or minus 1 standard deviation, or plus or minus 2, or plus or minus 3, this is a relative measure, so we can't use the coefficient of variation in that manner. But what this tells us, and again, I'm not going to get too far into this, but what this tells us is, and the reason this is riskier, is we're standardizing this. We're dividing this by the expected return. So what this tells us is for asset A has 0.094 units of return, or excuse me, units of risk per unit of return. I always get that backwards. Units of risk per unit of return. Asset B has 0.377 units of risk per unit of return, and typically a unit of return is 1 percentage point. So what this is saying is, if we invest in asset A and we expect to earn a 1% return, we're taking 0.094 units of risk. If we invest in asset B and we expect to earn a 1% return, we're taking 0.377 units of risk. So for the same return, asset B is riskier than asset A. Does that make sense, kind of how that works? Now, it kind of throws us off a little bit here because both of these have the same expected returns, and typically we said they would have different expected returns, but it's doing the same thing, okay? So if this had a, for example, a 20% return, and B had a 17% return, we would simply divide by 20 and divide by 17. Okay, but again, we're standardizing this. So measuring risk, two ways, standard deviation and coefficient of variation. That's measuring the risk of a single asset. Okay, now, we've talked about single assets, but typically in the real world, most investors are going to have a portfolio. And we said on Thursday, a portfolio is simply a collection of assets or a collection of investments. So it could be all the stocks you've invested in, all the bonds, all of the rental property, all of the gold, silver, whatever it might be. And basically what we're looking at is if we're going to invest additional money in something, we want to know how does this new investment impact the risk and return of our current portfolio. That's the key. We've got a current portfolio and we want to know if we put more money into something, what is it going to do to the risk and return of our portfolio? Because what we're trying to do is, as investors or as a financial manager, we're trying to create what's called an efficient portfolio. So you need to know this definition for the second test, okay, an efficient portfolio. And it says an efficient portfolio is a portfolio that, excuse me, maximizes return for a given level of risk or minimizes risk for a given level of return. So let me say that again, and I'll kind of explain this. It's a portfolio that maximizes return for a given level of risk or minimizes risk for a given level of return. This is the most efficient portfolio that we could put together as an investor. This is what we're trying to accomplish. Now, the way this works is, and think about this, we're trying to put together, for example, let's say that we have a certain level of risk as an investor that we're willing to accept. And we're different. We talked about that. We all look at risk differently. But let's say I want a portfolio with a certain level of risk. We'll talk about beta coefficients later, but let's say it's going to have a certain beta coefficient of maybe 1.5. Well, it would make sense that if I'm going to take a certain amount of risk, let's say a portfolio with a beta of 1.5, I would want to put together the group of investments that is going to provide me with the highest rate of return for that level of risk. That just makes sense. Why wouldn't I want the highest return possible if I'm going to take a certain level of risk? Or another way of looking at this is, let's say I have a given level of return I want as an investor. I want to invest and I expect to earn a 10% positive return per year. Okay, so that's what I want my portfolio to do. Well, the most efficient portfolio is the one that's going to provide me, I think, with a return of 10%, but it is going to minimize the risk that I'm taking while still providing me with that 10% return. So does that make sense, kind of how this works, this most efficient portfolio? And if you take, for example, if you take an investments class, Finance 333, you'll look at something called an efficient frontier. And it'll show return on one axis, it'll show the risk level on the other axis, and so you'll kind of go into, okay, why is this important? How do we accomplish it? That type of thing. Okay, but for purposes of this class, you just need to know the definition of an efficient portfolio, which is given here. So everybody good with that? Pretty simple, pretty straightforward. Now, this is talking about the risk of a portfolio, and again, we're not going to get into calculating a lot of statistics regarding a portfolio. And there's a really simple reason for that, and the reason is when you're dealing with even just a 2-stock portfolio, okay, a portfolio that contains 2 different stocks or 3 different stocks, really small portfolios, it gets really hard mathematically to calculate something like the standard deviation. The math just gets crazy compared to a 1-stock portfolio, which is what we calculated earlier. So that's why in this class we don't worry about calculating the standard deviation or the variance or anything else of a 2 or 3-stock portfolio. But I do want you to be able to calculate, this is the risk of a portfolio, and this is simply the weighted average of returns of the individual assets inside the portfolio. So what this says is, if we wanted to calculate the return of a portfolio, which is R sub P, return of a portfolio, we're simply going to take the weight, the percentage weight that asset 1 makes up of the entire portfolio, multiplied by the expected return for asset 1, plus the weight of asset 2 times the expected return of asset 2, and we're just going to do this for as many assets as we have. If we have 10 assets, we'll do it 10 times. If we have 2 assets, we'll do it 2 times. And again, there's nothing complicated about this. This is just a weighted average. So it's simply saying, what do we expect to earn on our portfolio as a weighted average? And on the next slide, here's an example of this. And I just picked out 3 stocks here. I picked out, these are the ticker symbols. We'll look at that in a minute at a ticker symbol. But this is Ford, Facebook, and Apple. So 3 pretty well-known stocks. And I just made up these numbers. So let's say we've got a portfolio that totals $100,000. We own $20,000 worth of Ford stock. We own $30,000 worth of Facebook stock. And we own $50,000 worth of Apple computer stock. And then, so now sometimes you're given the weights or the W's that are in this formula, okay? The weight of asset 1, the weight of asset 2, etc. If you're not given the weight, you can calculate it. And to calculate this, let me make sure it's not on the next slide. Okay, it's not. So to calculate the weight, we're simply going to take the, okay, where's my pen? Right, okay, here we go. So the percentage weight is equal to the dollar value of an asset, which is typically a stock, but it doesn't have to be, divided by the dollar value of the portfolio. So it's a really simple formula. Actually, this is given to you on for the next test on your formula sheet. And so if we wanted to calculate this, for example, for the first one, which I think was Ford Motor Company earlier, we had $20,000 worth of Ford stock divided by the total, which is $100,000. And so this gives us 0.20 or 20%, which is the percentage weight. So now sometimes again you're given the weight. It'll just tell you stock 1 makes up 14% of the portfolio, stock 2 makes up whatever, but if you're not, this is how you would calculate it. Okay, so based on that, we can go back to our example. Now notice for each weight was given here, and the stock's return, this has to be given to you. Okay, so you will be given these numbers. So we expect to earn 10% on our Ford stock, 25% on Facebook stock, and 15% on our Apple computer stock. And the formula simply tells us to calculate the weighted average for the portfolio to multiply the weight times the return. So that's what we're doing at the bottom here. We're simply taking the 20% weight of Ford times its expected return of 10%, plus the 30% weight of Facebook times its expected return of 25%, plus the 50% weight of Apple times its expected return of 15%. We work through the math, add them together, and we come up with an expected return for our portfolio of 17% positive. Okay, so how's the math on that? Is everybody comfortable with that? Pretty straightforward. Again, you will see one of these on test number 2. So it's not a surprise as to what will be coming at you. Now, I can't tell you, I don't remember exactly whether we have it set up where you're given the weights or you calculate them, but you can handle it either way. So it's not really a big deal. All right, now we've talked about a portfolio and an efficient portfolio and the return of a portfolio. Now let's talk for just a minute about the risk of a portfolio. And again, we're not going to get into the calculation of risk, but I'm going to explain to you how another concept in statistics that you studied, something called correlation, can actually be used and is useful to us as investors. Now, somebody remind me, what does correlation mean? When you talk about correlation in statistics, what does that mean? Okay, that's perfect. A relationship between two variables, or in this case, or we'll change it a little bit, a relationship between two series of numbers or two series of stock returns. So basically, correlation is how does one stock move in relationship to another stock? Do they both increase together? Do they both decrease together? Does one increase while the other one is decreasing? And so that's what this is talking about here. It gives us the definition of correlation. We can have positive correlation, which means our two series of numbers move in the same direction. We can have negative correlation, which means they move in the opposite direction. Now, that tells us if they move together or opposite, but it doesn't tell us at what strength do they move together. How precisely do they move together, or how much difference is there in their movement if they move in opposite directions? So for that, we need something called a correlation coefficient. And again, you don't have to calculate this, but you may remember from stat that your correlation coefficient ranged between negative 1.0, which is called perfect negative correlation, and positive 1.0, which that's called perfect positive correlation. Perfect negative correlation means two numbers move in the exact opposite direction with the same strength. Perfect positive correlation means these series of numbers or these series of stock returns move together exactly with the same strength. For most stock returns, they're going to move together, but it's not going to be perfectly together. Typically, if you look at different studies, it'll show that most stock returns have a positive correlation coefficient of around 0.6 to 0.7, something like that. So it's not perfect positive correlation. But what that means is, and you'll see this later in the semester when we look at stocks and buying and selling stocks, since they have a pretty high positive correlation coefficient, that means that if one stock is up for the day in value, typically other stocks are up for the day. So if you look at if you go downstairs on the first floor where we've got the big television screens in the financial services suite, and you're looking at stock returns, you'll see a lot of green for the day if stocks are up, because most stocks follow each other. Or you'll see a lot of red, which means if stocks are going down in value, almost all stocks go down in value, but not every one of them. So based on what we know about correlation and correlation coefficients, what we can do is, and this is a graph that simply shows, I used to try to do this on the board, but it's much neater here, so I just show you here. This is two stocks. This is over time, and it's showing the return. So what this shows is this is perfect positive correlation. So as one stock is increasing in value, notice the other stock is increasing in value. When one stock is decreasing in value, the other stock is decreasing in value at the same speed by the same amount. Perfect positive correlation. And then this is a graph of perfect negative correlation. Notice when one is going down in value, the other is going up in value. When one is going up, the other is going down. So this is perfect negative correlation. But again, we don't see this in the real world. This is just kind of for reference purposes in our textbook. But based on this, we can use diversification and the concept of correlation to help us as investors. Because what we're trying to do is we're trying to reduce the risk of our portfolio while still maximizing its return. And that goes back to the efficient portfolio definition that we looked at about 4 or 5 slides ago. So what this says is, to reduce overall risk of your portfolio, it's best to diversify by combining or adding to the portfolio assets that have the lowest possible correlation. So in other words, with diversification, now let me take a step back here for a second. When it comes to diversification, there's a really simple concept, and there's an old saying. It has to do with eggs, and it has to do with a basket. Anybody know what that saying is? Okay, great. Don't put all of your eggs in one basket. You've heard that a lot in your lifetime, probably. Somebody explain to me, though, why can't I put all of my eggs in one basket? I mean, literally, why can't I put all my eggs in one basket? Okay, so well, let me ask you this, and she's right. How many of you have actually gone into a hen house and physically gathered eggs? Anybody in here? So a few of you have. Okay, that's about the best number of responses I've had in 2 or 3 years, because typically each year the number of responses to that gets lower. And when I was a kid, I did the same thing. I grew up around a lot of farmers, and right next door there was a farmer, and they had some hens, and so I can remember as a little bitty kid going to the hen house with the farmer's wife, and I'm little, and she takes me out the hen house, and I'm trying to grab the eggs, and I'm so small that you kind of just have to reach up into the nest, and you really hope a chicken snake's not up there. But you get the eggs, and then you put them in a bowl. I never saw them in a basket, but you put them in a bowl, and you walk back to the house. Now, if you're walking back to the house with your bowl of eggs and you happen to trip and fall, you're not having eggs for breakfast. Okay, so that's where the old saying comes from. Don't put all your eggs in one basket. Although, I really don't see the value if I put them in 2 bowls and walk back to the house and fall. I'm still probably going to break all the eggs, but that's besides the point, okay? That's a philosophy discussion. That's not a finance discussion. But what this is saying is, to diversify your portfolio, you don't want to put all of your eggs in one basket. And to help us with diversification, we want to add to our portfolio stocks that have either negative correlation, which would be best, or low positive correlation. Now, you may be looking at this and thinking, well, if a stock has negative correlation with the portfolio, that means as the portfolio is moving up in value, the rest of the stocks, this one stock is moving down in value. Or the opposite would occur. One stock's moving up, the rest of the portfolio is moving down. Why, as an investor, would you want to do that? Because as an investor, what I want to do is I want to invest my money in stocks that are going up all the time, that increase in value every year. I don't want stocks that go down in value. I want all winners all the time. But there's a problem with that. Does anybody know what the problem is? As an investor, you can't pick all winners all the time. Okay? It's just a fact. You can do as much research as you want. You can spend as much money on newsletters and inside, well, I'm going to say inside information, but I'm going to say not true insider information. We'll talk about that in the stock chapter, okay? That's actually illegal. But what's called insiders newsletters and all the technology you want, you're still going to invest in stocks that go down in value. If you talk to somebody and they tell you they've never invested in a stock that's lost money, one of two things has happened. One is they started investing yesterday, or two, they are lying to you, because everybody picks bad stocks. But what we're trying to do is, with this concept of diversification, is we're trying to minimize the risk that we're taking while still earning the highest return that we can. So what this is showing is, okay, now let's take a look at this. Asset F, Asset G. If we have money to invest and we invest it all in just one stock, let's say it's Asset F, Stock F, whatever that is. Now, this horizontal line here, this is the expected return for Asset F. And we don't know what it is. Maybe it's 8%, whatever it might be. Now, notice the first, let's say these are years, okay? So the first year, we didn't earn the expected return. We earned more than the expected return. We earned way up here. We earned more than we expected. And the difference between what we thought we were going to earn and what we actually earned is called what? And it's the first definition we looked at in this chapter. The name of the chapter is Risk and Return. Okay? So that's risk. So the difference here between what we earned and what we thought we were going to, this is risk. Notice the second year. We thought we were going to earn here at the horizontal line. We earned this. We earned less than we thought we were going to earn. Again, that's risk. Now, notice Asset G. Asset G, the first year, we thought we were going to earn here. We earned less than that. The second year, we earned more than we thought we were going to earn. And notice Asset F and Asset G are moving basically, they're almost perfectly negatively correlated. While one's going up, the other's going down. So what if we have this great idea that instead of putting all of our money in F or all of our money in G, why don't we put half in each stock? And what's going to happen is our risk level, notice it goes to almost zero because we're almost operating on the horizontal line what we expect to earn. So almost no risk. But the expected return doesn't change from investing in each stock individually. So as an investor, we would much prefer to be here than to be on either one of these. And the reason here is pretty simple. We've got the league playoffs going in baseball right now, so I'll use a baseball analogy. In baseball, home run hitters, which are fantastic to watch, also do what a lot? They strike out a lot. So it's either the long ball or you're striking out. As an investor, you're trying to stay away from that home run hitter mentality. Sure, we'd all like to invest, we'd all like to be here, okay? So we expect to earn this return and we earn more, we hit a home run. Fantastic. But the problem is, if you have the strikeout years, which is here, because it's hard to recover from those strikeout years. I can show you a perfect example just using some really, really simple numbers. So let's say, for example, that you start out, you want to invest, and you have $100. You invest in one stock. In that first year that you invest, your stock loses 50% of its value, which can happen. So after the first year, you've lost 50% of your investment, so you now have $50. And this represents a negative 50% return. What return do you have to earn just to get yourself back to having $100 invested? You have to get yourself back to $100, you have to earn a positive 100% return. And this is not easy to earn. At 7% per year, 8% per year, 9% per year, 10% per year, it's going to take you a long time to get up to that 100% return. So the first year, you lost half the value, and it may take you 4, 5, 6, 7 years to get back to where you started originally, which is with $100. So you can see this is a huge strikeout year. And as an investor, that's what you're trying to stay away from. So I'll keep going with the baseball example. As an investor, home runs are fantastic. And if you get lucky occasionally and you pick a stock and it's a winner, man, life's good. But what you want to be as an investor, you want to be a singles hitter. You want to just slap the ball around all over the field, get on base, get on first. You're not worried about hitting a home run because you want your return on your portfolio to increase nice and steadily year after year after year. Positive 6%, positive 9%, positive 12%, positive 4% per year. But again, you're trying to stay away from these big strikeout years as an investor. So does this make sense in terms of what we're trying to accomplish here with diversification as investors? And you can actually look it up. I can show you in a minute. We can look it up to see, okay, but how are stocks moving together? Which stocks do I choose? So that information is out there for you that you can use to help you pick stocks that have negative correlation. Now, it's hard to find stocks that are negatively correlated, but occasionally you can. Oftentimes, you're looking for stocks that have low positive correlation. So, for example, let's say during a recession. During a recession, a lot of luxury company stocks, they're hit pretty hard. Because during a recession, if you're trying to put food on the table and you're trying to pay rent, you're not really worried about buying luxury products. So those take a big hit during a recession. But what about companies like Dollar General or Walmart or other discount retailers during a recession? It would make sense that they would tend to do just a little bit better during a recession than would luxury products. So if you think about investing in terms of, okay, what am I investing in? Am I investing in the computer industry? Am I investing in the retail industry or the food industry? And we can break it down from there because you can take industry classifications and you can take them down to really, really small levels. You can put together a really, really good portfolio of stocks. Now, what some people will tell you is, well, don't worry about that. Just invest in a mutual fund. Anybody in here, can you tell me what a mutual fund is? I'm sure some of you probably own shares of a mutual fund. And it doesn't have to be the perfect textbook definition. Okay, then I'll step in and help you out. A mutual fund is simply an investment where instead of you as an investor having to have maybe 50 or 60 or $100,000 to invest to adequately diversify, a mutual fund, when you buy shares of a mutual fund, it invests in shares of a lot of different stocks. So by buying one share of a mutual fund, you are diversifying your portfolio. And there's thousands of different mutual funds. Some invest just in stocks. Some just invest in big stocks. Some invest in medium-sized company stocks. Others invest in small company stocks. There are mutual funds that just invest in technology companies. Mutual funds that just invest in pharmaceutical companies. Some mutual funds invest in stocks and bonds. Some mutual funds invest in just bonds. I mean, there's so many kinds of mutual funds. But the reason I'm bringing this to your attention is I hear people sometimes say, well, as an investor, I'm adequately diversified because I have invested in a mutual fund. Well, that may or may not be correct. And the reason is, if you invest, for example, in shares of a technology mutual fund, all of the stocks within that mutual fund are technology-based stocks. And what happens is technology, just like other industries, tend to move together. If technology is increasing in value, if one stock's increasing in value, the other stocks are almost surely going to increase in value. But if they go down in value, let's say we have a technology bubble burst, and they all drop by 35%, most of the others in there are going to drop together. So if you invest in a mutual fund, take a look at what stocks does that mutual fund invest in. What's the purpose of, and that has to be given to in what's called a prospectus. So you can look it up online. You can read the prospectus. What are the goals of the mutual fund? What are the top 10 holdings in terms of the types of stocks? And you can pretty much tell, yes, this mutual fund is well diversified in different sectors, or this is all technology, this is all pharmaceutical, this is all whatever. So just because you're invested in a mutual fund doesn't always mean that you are adequately diversified. And this table is in your book, I believe, and it just shows you what we just mentioned, okay? So we've got 3 different stocks here, X, Y, and Z. X and Z are perfectly positively correlated, and X and Y are perfectly negatively correlated. So what this is showing us is if we look at the expected value and the standard deviation of each stock by itself, we expect to earn 12% and the standard deviation is 3.16%. If we invest in X and Y, put half our money in X, half our money in Y, notice that since they're perfectly negatively correlated, the expected return doesn't change. We still expect to earn 12%, which is good. But look what happens to the risk level that we're taking. It's basically a risk-free investment. And there aren't many risk-free investments, okay? But this is kind of how, in the textbook world, perfectly negatively correlated stocks would work. And notice with X and Z, these are perfectly positively correlated. So if we say, hey, we're going to put half our money in X, half our money in Z, we're not actually diversifying because they move together. And so notice the expected return doesn't change, but also the risk level of these 2 stocks together is no different than they are by themselves. So we're not gaining anything by diversifying. All right, so are there any questions about what we've talked about so far? Risk, return, any of that? Everybody pretty good with this? How many people in here have ever purchased or invested in shares of stock, or maybe you own shares of stock or shares of a mutual fund or bonds or just some kind of investments? Anybody? So a few of you have. Okay. So some of you have. Now, if we take a look at the next slide, we're going to move to something called the capital asset pricing model. And this is actually a pretty big area of finance. It's something that's been studied a lot. And what it says is the capital asset pricing model is the basic theory that links risk and return for all assets. So what this is saying is, up to this point, we've talked about risk, I think everybody understands what risk is. We've talked about return, and you know how to calculate return. And we've said if you expect a higher return, you have to take more perceived risk. I think we've established that fact, okay? The problem is we haven't put a number with a risk level. So we've said if you take more risk, you expect a higher return. Well, okay, but if I take more risk, what number should I expect? Should I expect an 8% return, 10, 12, 14, 16, 18, 20? So the capital asset pricing model lets us put together a risk with a numerical return, which this is a really, really big breakthrough in finance when it was discovered. You look at it now and you may think, well, okay, that's not really a big deal. Okay, I could have come up with that myself. But whenever it actually was discovered, this was a pretty big breakthrough in finance. This has been studied a lot and been written about a lot in finance. Now, when it comes to the capital asset pricing model and types of risk, so I said in finance there's 100 different types of risk. Here's some other different types. So we've got total risk, and it says total risk is a combination of a security, and that means a stock, okay? So a stock's non-diversifiable risk and diversifiable risk, and we can define each of these. It says diversifiable risk is the portion of an asset's risk that can be attributed to firm-specific events. So if you invest in a company, there are certain events that might happen to that specific company that's only going to affect that corporation. For example, lawsuits. If this company is sued, for example, if you're the airbag manufacturer that's had the millions and millions and millions and millions of recalls on your airbags, you're probably in trouble if that's the only stock you've invested in. Or a labor strike. If you invest in a company that has a labor strike and that's the only company you've invested in, you're probably going to see the value of your stock go down for two reasons. One is the workers are on strike. And two, when they do go back to work, if they do go back to work, they're probably going to go back to higher wages, which means profitability is going to be cut. So that's what we call diversifiable risk. And the great thing about diversifiable risk is we can actually do away with diversifiable risk as investors. Now, this is also called unsystematic risk. The other type of risk is non-diversifiable. It says it's the portion of an asset's risk that can be attributed to market factors that affect all firms. It's also called systematic risk. So think of this as factors or risk associated with the economic system. That's the term systematic risk. So things like a recession. A recession tends to hit all businesses or almost all businesses. So you can't get away from it. Or sometimes a war, or in the upcoming presidential election. You know, it's going to have an effect on the entire economy. You can't get away from it. So what this means is when we're looking at risk and we're looking at the capital asset pricing model and we say that the higher the expected risk or perceived risk, the higher the expected return, we're talking about the higher the non-diversifiable risk. This is what we're left with, because if we are adequately diversified, we can do away with all diversifiable risk. It goes to zero. So that's what we're working with. So you need to know the definition of diversifiable risk and examples of it, and the definition of non-diversifiable risk and examples of it. And these two together equal total risk. So the only relevant risk that we're left with is non-diversifiable risk. Now we can see this. This is a graph. This is in probably every finance textbook ever written in some one form or another. So this shows us that as we invest in more stocks, now these are different company stocks. These aren't individual shares. Okay, this is not, you know, 1 share of Walmart, 5 shares of Walmart, 10. This is Walmart, and then Walmart and 4 other companies, and then Walmart and 9 other companies. So these are different company stocks. Now notice the risk, and what happens is as we invest in more and more companies, the diversifiable risk decreases. And it decreases to the point where it's actually touching our horizontal line here. And so what this shows us is that we're left with after a certain number of investments, and some studies show 25, some show maybe 40 different companies. We've done away with all diversifiable risk, and we're left with non-diversifiable risk after this level by investing in 20, 25, 30, 35, 40 different companies. But the problem is most of us don't have enough money on hand to buy enough shares of stock in 40 different companies. That's why mutual funds are such an attractive investment for a lot of investors, because small investors can get the benefit of diversification without having a lot of money to invest. So once we've looked at the risk, and non-diversifiable risk, we can then look at something called the beta coefficient. And the beta coefficient, it says this is a relative measure of non-diversifiable risk. It's an index of the degree of movement of an asset's return or a stock's return in response to a change in the market return. Now, a couple of things about this before we actually look at a beta coefficient. The market beta is always 1.0. So we're going to measure the risk of a stock as to how does it relate to 1.0. If it's higher than 1, it's riskier than the market. If it's less than 1, it's less risky than the market, or less risky than average. And what we do is, and again, I'm not going to get too deeply into this, but we find the stock market's return. And that's easy to find. You can use we have to use some kind of substitute or a proxy, such as, for example, the S&P 500. So if we look at the daily return on the S&P 500, we can set up an Excel spreadsheet. We can have a column of, let's say, 3 years worth of daily S&P 500 returns. And we could also pull the daily returns on a stock. For example, Under Armour. So we can have 3 years worth of Under Armour stock daily returns. So we've got 2 columns, column A, column B, in an Excel spreadsheet. In your stat class, you probably talked about something called regression. And a simple regression is where you have one independent variable, one dependent variable. And in Excel, it takes about 5 seconds to run a simple regression. Now, you're going to get a lot of output, but among that output, you're going to get what's called a beta coefficient. And that beta coefficient is going to be a number like 1.36. What that means is, compared to the market, Under Armour stock moved 1.36 times as much when the market was up, or it moved 1.36 times as much when the market was down. So Under Armour stock would be considered riskier than the market because it's higher than 1. If it was less than 1, it would be considered less risky than the market. And if its beta coefficient was 1 exactly, it would be more risky than the market. So this is basically what the beta coefficient is telling us. Okay, so it measures the degree of movement of a stock's return in response to a change in the market's return. Each stock has a beta coefficient. And again, the way it works is, let's say, here's an example, if stock X has a beta of 1.4, and the market increases by 10%, we would expect stock X price to increase by 1.4 times 10%, or a positive 14%, because it has a beta higher than 1. Now, that's great if the market is increasing, but what if the market goes down by 10%? Then stock X is expected to go down by 1.4 times 10%, or it's expected to decrease more than the market, 14%. So that's how these risky stocks tend to work. In an up market, they do great, and you're really impressed with yourself and your investing ability. In a down market, they do terrible, and you're really disappointed in your investing ability. Okay? And this is what I mentioned earlier. Market is 1. You need to know that for the test. Okay? The market beta is always 1.0. And we find the beta through a simple regression. Okay, now this is just a kind of a good little study table for the understanding beta. So it tells, if a stock has a beta of 2, positive beta of 2 is twice as responsive as the market. A beta of 1 is the same response, 0.5, half as responsive. And then you could also have occasionally negative betas, although you don't see those very often, but you can have negative betas. And so that means these stocks are negatively correlated with the market. When the market goes up, these stocks go down in value, or the opposite can occur. So in looking at this and looking at table 8.8, these are some betas, and these are old on purpose because I wanted to show you, compare what was happening in 2010 with what's happening now. And the reason that this is such an interesting time is because this was while we were right in the middle of our recession. We had the financial collapse in 2008. Stock markets were still all over the place in 2010. And the stocks that you see up here, you've heard of most of these, okay? Amazon, GE, Procter & Gamble, Citigroup, Carnival, Ford, Apple, Monster, Beverage, and Netflix. But what I wanted you to take a look at is the beta coefficients of some of these companies. For example, Citibank, or Citigroup is the holding company, has a beta of 2.6. Now, these are 5-year betas. So what this means is these go back, the stock returns for these stocks 5 years. So you can have a 2-year beta, a 3-year beta, 5-year beta is about as far back as you go. So this means that over the last 5 years, Citigroup's stock price has moved 2.6 times as much as the average stock in the market. Now, if you study the stock market, you see a bank, especially something like Citibank that's been around forever and is a really, really stable company, typically, a beta of 2.6 is almost unheard of. You look at this and you think something is wrong here. The markets must have been going crazy during this time period, and guess what? The markets were going crazy during this time period. So you don't see this very often. I mean, if you look at something like Ford Motor Company, Ford's been around forever, and typically the way Ford goes, the rest of the economy goes. But remember, what was happening with gas prices back in 2010? We're seeing gas prices of $4 a gallon. They were predicting gas prices of $6, $7, $8 a gallon by now. And so Ford sells a lot of what? Trucks. They use trucks, SUVs, big vehicles that use a lot of gas. And so the market's looking at this and they're saying, man, Ford, if you remember back at this time too, not only banks were being bailed out, automakers were being bailed out by the government. Ford, General Motors, because we were looking at gas prices going forward, their lineup of cars and trucks, they are not green enough. They're not, I mean, people aren't going to buy their trucks if gas is $7 per gallon. So they're going to fall off the face of the earth. And you saw Ford stock way up and way down during this 5-year time period. That's why it has such a high beta. On the other hand, if you look at companies like Netflix actually hadn't had much time to move in this time period. Monster Beverage, low beta, Procter & Gamble, Amazon. So what this is saying is, for Amazon, whatever's happening in the economy doesn't really affect Amazon sales. People are going to buy their products from Amazon, whether we're in a recession, whether we're in an economic expansion, they're going to buy their products from Amazon. Okay? And you can take a look at, you can see companies listed here. For example, here's Ford Motor Company today, and if I just went to I guess it's Yahoo Finance, I think, or maybe it's Google Finance. But you can see their beta here is now down to 1.28. That's a little more indicative of what Ford Motor Company does year in and year out. They're not a super performer anymore. They've been around a long time. They're a huge company, so they're not going to have they're not going to perform fantastic, but they're going to sell cars and trucks. They're going to be a nice, steady performer. You can look at, let's see if we put in Amazon, and we look at its beta. Its beta now is 1.2, which is again about what you would expect. Amazon's going to perform pretty well no matter what's happening in the economy. Now, one surprising stock is if you look at Under Armour. And if you look at the beta of, well, I don't know what UB is, but let's try UA. Under Armour, its beta is 0.53, which is, you kind of would expect a high-flying stock like Under Armour to have a higher beta than this. I mean, Under Armour stock price has grown tremendously over the last few years. If you got in early with Under Armour, you're a really happy investor. But it has a pretty low beta. So what this is telling me is during an up market or a down market, people have been buying Under Armour products. Despite maybe the price being a little bit expensive for some consumers, they're still going to buy those products. Shirts, hats, golf equipment, hunting equipment, coats, whatever. I mean, Under Armour's in everything now. You can look at, for example, Citigroup and their beta, which is still a little bit high for a big bank like this, 1.86. But again, this shows the economic instability of our banking system still 8 years after our last financial crisis. Still pretty high. So is this, everybody kind of following this, making how this makes sense and what a beta coefficient does and what it tells us? And typically, if you look at the beta of, let's say, a utility company, and a utility company is like an electric company or a gas company or a water company, for investors, they tend to be really conservative investments. So most utility companies, for example, electric companies, they have a beta of like 0.5, 0.4, 0.6. What that means is if the market is up by 10% and a stock has a beta of 0.5, it's up by 5%. So in an up market, it's up less than the average. In a down market, it's down less than the average. And people may think, well, that's pretty boring. Why don't utility companies' stock prices move more? But think about this. With an electric company, let's say that yesterday you received a 25% pay raise at work. Big pay raise. So today, you get up this morning, you're making a lot more money now than you did yesterday. You're leaving your house, you're going out the door, you turn the lights off, and then you say, you know what? I can afford to leave the lights on today while I'm gone to work. Is that how we think? No. We're going to turn the lights off just like we did. So we're not going to use a lot more electricity than before. We're not going to use a lot less. Nothing's really changed, even though we're making more money. Are you going to take 4 showers per day now instead of 1 or 2 because you're making more money? No, you're not going to use much more or less water. It's going to be the same. So utility companies don't move much, unlike the Under Armours, the Monster beverages, the whatever. These tend to have high betas, although during this time period, it's really odd because the riskier stocks had low betas. The less risky stocks historically had high betas. This was a really, really strange time period. That's why I leave this example here. Okay, it's not because I'm too lazy to update it to 2016. It's because I want you to see that sometimes beta coefficients, even though what we say about them is typically true, sometimes the market can get way out of whack. All right, questions about anything today before I let you go? And we will, on Thursday, we will finish up with chapter 8. We will also talk about and vote on the date of your second test on Thursday. Okay? We'll finish chapter 8 on Thursday. We'll probably spend one day reviewing, but we can have your test just about, we can have it. The earliest date would be a week from Thursday, or we can have it the following week sometime. So be thinking about those dates. Remember the 2 o'clock meeting today, room 254 if you're interested. Otherwise, have a good day.